Hey everyone, welcome back to Learn AI with Jay. Let me ask you a simple question. Have you ever wondered how ChatGPT writes essays, how Netflix recommends movies you actually enjoy, or how Google Photos recognizes your face in thousands of pictures? It almost feels like magic. But here's the truth. Behind all of these amazing AI applications is something surprisingly simple. It's called linear algebra. Now I know what you're thinking. Math? Seriously? I came here to learn AI. Don't worry. This isn't going to be one of those boring math classes where we fill pages with equations. Instead, imagine we're sitting together over a cup of coffee and I'm explaining this to you like a friend. By the end of this video, you'll understand why linear algebra is called the language of AI. So, let's dive in. First of all, what is linear algebra? Imagine you walk into a supermarket. You look around and instantly recognize apples, milk, chocolates, vegetables, and biscuits. But if a computer walked into the same supermarket, it wouldn't see any of those things. It would only see numbers, millions and millions of numbers. Every color, every pixel, every shape, everything becomes numbers. And linear algebra is simply the science of organizing and working with those numbers. That's why AI depends on it. Without linear algebra, AI wouldn't know how to process information. Let's start with something incredibly simple. Start with something incredibly simple. Imagine I ask you, how old are you? You reply, I'm 25. That's just one number. In mathematics, we call that a scalar. Sounds fancy, but it's literally just a single value. Temperature, scalar. Your salary, scalar. The number of subscribers on your YouTube channel, scalar. One value, nothing more. Easy, right? Now let's make things a little more interesting. Suppose I ask for your profile. You tell me, I'm 25 years old. I'm 175 centimeters tall. I weigh 70 kilograms. Now, instead of one number, we have three numbers together. That's called a vector. Think of a vector like your identity card. It doesn't describe everything about you, but it stores multiple pieces of information together. And here's something cool. AI represents almost everything as vectors: people, movies, songs, products, even words. Yes, even the sentence you're listening to right now eventually becomes vectors inside an AI model. Pretty amazing, isn't it? Let's imagine you're shopping on Amazon. Every product has information: price, rating, popularity, weight, number of reviews. These values together create a vector. Now, AI compares one product vector with another. If two vectors are similar, Amazon recommends that product to you. So, the next time Amazon says customers also bought this, remember, it's actually comparing vectors behind the scenes. Now let's level up. Suppose instead of storing information about one person, we store information about an entire classroom. Student 1, Student 2, Student 3, Student 4. Each student has marks in different subjects. When we arrange all those vectors into rows and columns, we get something called a matrix. But honestly, don't let the name scare you. If you've ever opened Excel, you've already used matrices. Every spreadsheet is basically a matrix: rows, columns, numbers. That's it. And here's where AI gets really powerful. Imagine Google has billions of search results, or Netflix has millions of movies, or ChatGPT has billions of words to process. How do they manage all that information? Matrices, huge matrices. They allow computers to organize and process enormous amounts of data efficiently. Now you might hear another scary word: tensors. Relax, they're actually very easy to understand. Imagine one Excel sheet. That's a matrix. Now imagine stacking hundreds of Excel sheets on top of each other. That's a tensor. Images are tensors. Videos are tensors. Even voice recordings can be tensors. Deep learning models spend their entire lives working with tensors. So, remember this simple ladder: scalar, vector, matrix, tensor. Every step simply adds another dimension. Now, here's something really fascinating. Let's talk about words. When you type "I love pizza" into ChatGPT, the AI doesn't actually read those words like you and I do. Instead, it converts every word into a long list of numbers. Those lists are called embeddings. So, inside the AI, there aren't really words, there are only vectors. And because similar words have similar vectors, the AI understands relationships. For example, king and queen end up close together, doctor and hospital end up close together, cat and tiger end up closer than cat and airplane. That's all linear algebra at work. Now let's play a little game. Imagine Netflix wants to recommend a movie for you tonight. How does it know what you'll enjoy? Well, your viewing history becomes one vector. Every movie becomes another vector. Then the AI compares them. If they're very similar, Netflix says, you might like this movie. It isn't reading your mind, it's comparing numbers. And that's one of the coolest applications of linear algebra. Let's talk about something called the dot product. Don't worry, no formulas, just intuition. Imagine you and your best friend both love cricket, movies, travel, and technology. You're probably very similar. Now imagine another person who likes gardening, cooking, and painting. Your interests don't match much. The dot product is simply a mathematical way of measuring similarity. The higher the similarity, the higher the score. Search engines use it. Recommendation systems use it. ChatGPT uses similar concepts when comparing embeddings. And suddenly, AI starts making much more sense. Here's another interesting question. Why are companies spending billions of dollars on GPUs? Why not just use normal processors? Well, training AI is basically performing billions and billions of matrix calculations every second. GPUs can perform thousands of calculations simultaneously. That's why they're perfect for AI. In fact, without GPUs, modern AI probably wouldn't exist in its current form. Now let's connect everything. Suppose you upload your photo to Google Photos. How does it recognize your face? It converts your face into numbers. Those numbers become vectors. Then it compares them with vectors from your previous photos. If they match, it says, hey, that's you. No magic, just mathematics. The same thing happens when Spotify recommends music, when YouTube suggests videos, when Amazon recommends products, when Google Translate converts languages, when ChatGPT answers questions. Underneath all these amazing systems, there's a lot of linear algebra happening every single second. Now imagine you're sitting in an interview. The interviewer asks, why should an AI engineer learn linear algebra? Instead of panicking, you can smile and answer. Linear algebra helps represent and process data using vectors and matrices. AI models rely on these mathematical structures for similarity calculations, transformations, embeddings, and neural network computations. It's one of the core foundations behind machine learning and deep learning. Simple, professional, and impressive. But here's something I want you to remember. You do not need to become a mathematician. You don't need to memorize pages of equations. Most AI engineers use libraries like NumPy, TensorFlow, and PyTorch. The computer does the calculations. Your job is to understand what's happening. Think of it like driving a car. You don't need to build the engine, but understanding how it works makes you a much better driver. If you're starting your AI journey today, here's my advice. First, learn Python, then understand linear algebra. After that, move into machine learning, then deep learning, then generative AI, and finally AI agents. Strong foundations will always beat shortcuts. So, what's the biggest takeaway from today's video? Linear algebra isn't just another subject in mathematics, it's the language that AI speaks. Every chatbot response, every recommendation, every image recognition system, every voice assistant, every self driving car, every large language model, they're all powered by vectors, matrices, and mathematical operations working together behind the scenes. And once you understand that, AI suddenly becomes much less mysterious. The Guardian closing. And that's it for today's video. I hope you now see linear algebra in a completely different way. It's not something to fear, it's simply a tool that helps computers understand the world through numbers. If this video made linear algebra easier for you, make sure to hit the like button and subscribe to learn AI with Jay. Also, don't forget to press the notification bell so you never miss our upcoming AI tutorials. I'd love to hear from you. Before watching this video, were you scared of linear algebra? And what topic would you like me to explain next? Probability for AI, statistics, calculus, or neural networks? Drop your answer in the comments below. Thank you so much for watching. Keep learning, keep building, and remember, every AI expert you admire today once started exactly where you are. I'll see you in the next video.